Hey folks, it's me, Miss Rogers, and we're going to talk about the triangle exterior angle theorem today. This is the last unit of the semester in 6 weeks, so we're going to spend a little bit of time on it. And we've got several theorems and postulates to go through this unit. And we're going to get to that famous thing that you've heard of that geometry is known for, and that is proofs. So we're going to have fun this semester, this 6 weeks. All right, here we go. Triangle theorem. So let me find my notes page. It's somewhere here. Unless I closed it. Oh, well. Anyway, draw a triangle, pretty big one, so you can write in it. And then draw on the base and on the top, extend the bases so that it kind of looks like a pinwheel. Kind of like that. I should have drawn this one down, but I didn't. Okay. This is angle A. This is point D. This is angle B. This is point E. This is angle C. And this is point F. Inside I have little a degrees, little b degrees, and little c degrees. On the outside I have little d, little e, and little f degrees. Okay, so we've got a picture with a lot of stuff on it. All right, let's do some labeling. If we learned last unit that if I added A and let me find a color I like, magenta. A and B, and magenta is running out. Let's see one of these. Green is green. There we go. Try this one. A plus B plus C, they're going to equal what? 180. So we learned that last unit. But today we're going to talk about D, E, and F. So if I want to look at A, its supplement is D. I'm going to draw an arrow out here. A is on the inside, but D is on the outside. So they're communicating with that arrow. So how do I find out what D is? Well, A has to ask his buddies over here on this line, hey, come help me. I need your help. D doesn't know what his address is anymore. That's kind of silly, but you know, it happens, especially with little kids. Let's say it's a little kid one. So I have A is asking his buddies for help. So I have B up here and C down here. They're going to equal D over here. Okay? A, B and C and D are related. Sound good? All right. Well, let's say B gets lost. Here's B. That's a bright red, Christmas red. And it's talking to his buddy E. B is on the inside. E is standing outside his door, and he wants to know the address of the house. And the address of the house is known by A and C. So B has to ask his friends across the way to help him out. So B says, hey, A and C, help me out here. Oops, I don't want to write there. A plus C equals E. Are we good so far? I hope so. Well, let's do one more. We've got one more corner in our triangle. C is on the inside. F is knocking on its door from the outside and wants to know its address or phone number or some kind of number it has. It may be looking for a code to something, to the house across the street. Who knows? But here's the way we get it. So C is begging A and B to tell him the answer. So C says, hey, A plus B equals F. Not so hard, right? Well, let's put it to work. Let me find my worksheet that I closed out on accident. Let's see, Adobe Reader. I think I had it open from Adobe. So maybe it'll open. Anyway, let's start off with a triangle. Nope, not it. Not that. I must have opened it on the... Oh, there it is. I found it. Never mind. Okay, so example 1. I have a regular standard triangle, except it extends on the right-hand side, keeps going, has a ray. And this left-hand bottom corner is 50 degrees. I have X up here for the apex, and then 120 outside here. Wait a minute, I didn't talk about those a minute ago. Well, let's see if we can figure it out. That's on the green corner. So let's talk about the green a bit. So it had an arrow coming off of here, and it was circled. Who did it ask for help? It asked the two across. So I'm going to draw an arrow across. It asked these two guys for help. So I'm going to write an equation. 50 plus X is equal to what? The circle or the 120? It's equal to the outside. So the 120. Can we solve that problem? Sure. Not one. Yeah, 120. Yeah, that's right. So we take 50, subtract 120, we get X equal to 70 degrees. Easy peasy lemon squeezy. Let's get a little harder. Okay. Example 2. I have a right triangle. And it extends out to the right. And it's got a ray. Here's my right angle. Here's my right angle. The top apex is 70 degrees. And the outer side over here, the exterior, is X degrees. I only have one number. How am I going to work this one? Well, I got to find x, and it's related to this inside corner, because this inside corner has to help him out, because it's supplement to that one. Where does it get its help from? It gets its help from the ones across the way. So 70 plus that, 7D plus whatever this little red square means. What does that red square mean? Ah, it means 90. Good. Is equal to x. Now all I do is add them up, and I get 160 equal to x. So x is 160 degrees. Okay? Let's do example 3. My black pen doesn't like to draw upside down. Okay, so I have a ray going to the left this time, and outside it I have 11x plus 2. And on the inside I have 5x plus 10 and 58 degrees. And this one is sharing the red corner. Let's look at the red corner. This one right here. It goes to this supplement right there. But who does it go to for help? It goes across the way to these guys over here. Okay? So I'm going to say 58 plus 5x plus 10 is equal to 11x plus 2. That's a long equation. So I need to bring out my DCMAM. Okay? Do I have anything to distribute? No, I have no parentheses. Do I have to combine like terms? Yes. 58 and 10, so that's 68, plus 5x equal to 11x plus 2. So I did combining. Do I need to move a variable? Yes. I'm going to move the 5x over here. So that would be 6x plus 2 equal to 68. So I moved a variable. Do I need to add and subtract? Yes. I'm going to subtract 2 from both sides. That's 66 equal to 6x. Now I need to multiply and divide by 6, and I get 11 equal to x. There's my answer. It is not a degree, it is a value of x. Okay? Is that good? All right. Let's get a little harder now. Just a little. We'll do one more example. This one's a little more intense. Example 4. We've got a triangle. I'm going to make it kind of big. And it's going to the right. Got a ray on the outside. And I've got 10x minus 10. I've got 30. I have y. And on the outside here, I have 12x minus 4. And my instructions say find y. That's my instructions. Well, how do I do that? Well, it's in the green area, so I'm going to circle it. And it's going to give information to them, but it's going to get help from those guys. So let's write an equation. 10x minus 10 plus 30 is equal to 12x minus 4. I need my DCMAM. All right. So do I need to distribute? No. Combine like terms? Yes. Negative 10 and 30 gives me 20 plus 10x equal to 12x minus 4. I did my combine. Do I need to move a variable? Yes. I'm going to move the 10x over here. So I have 20 equal to 2x minus 4. So I moved a variable. I'm going to add and subtract. Add 4, so that's 24 equal to 2x. Then I'm going to multiply, divide. So 12 is equal to x. And that's all well and good, but it says find y. My instructions say find y. Y is right here. X is over here. And x is over here. Can I put this in for here and then do something with the triangle? Sure. So let's do this over here. Let's do 10 times 12 minus 10. That would be 120 minus 10, which is 110. So this is 110 degrees. I still don't know why. But I bet you this one is 140. How do I know that? 110 plus 30 is 140. Now, two things I could do. I could add these two and subtract from 180, or I could take and subtract 140 from 180 because these are a supplement pair. They're supplementary. So I'm going to take the pair right here since I know that one answer is 140. The other answer has to be 40. Because 140 plus 140 equals 180. And we're done. Hope you have a good time doing these. They're a little bit fun, kind of puzzle finding, and I'll see you next time.